or a probability density function? Well, a probability density function is just a function that tells us the relative likelihood of a random variable taking a certain value. For example, this PDF could be used to model how long we have to wait between each time we blink. Okay? So it tells us that the interval is very likely to be 6. You can see this is the probability that this is the highest probability that we're going to get. It doesn't tell us that it's going to be 6 seconds. It just says that, look, if you did it a lot of times, if you measured how much you wait between each time you blink, and no other factors sort of changed your scenario, then it's very likely that you're going to get a bunch of 6s or values very close to 6. Okay? But it doesn't tell us anything explicit or anything absolute. So, but it tells us that it's relatively more probable that we're going to get 6 seconds rather than, say, 30 seconds. Okay? Of course I made this graph up, but you get the point. But as with all probability functions or probability things, they have these two properties, namely that the probability at any given value, so for example the probability of getting 20 seconds has to be greater than 0 or equal to 0. Okay, so it can't be negative, that's the point. You can't have a negative probability. And also, the probability, if you take the interval from negative infinity to infinity, in other words, we take all the probabilities and add them up, we gotta get 1. Because we're saying the event has to happen somewhere completely. Okay? If you take all the probabilities, then that has to give us 1, because we've taken all the different possibilities into account, so we should have 1. Okay? So, usually you're going to see probability density functions of that form, namely 1 over some number times e to the minus 1 over the same number times t. Okay? In fact, this has a cool property. If your probability density function is laid out this way, mu is your expectation or expected value. Okay? It's very important because what that tells us, this is how we find it, by the way, what that tells us is, look, if you do this long enough, that should be the value that your your values are going to be close to. That's your expected value. Okay? That's what is most likely to happen. Okay? So this kind of problem is usually ones that you're going to have to solve in this section. And they're going to give you a probability density function. They're either going to not give you this normalized factor and say, oh, well, find a normalization factor that, makes this normalized, and all you have to do is just say, well, going from negative infinity to infinity, I need a constant. So for example, they wouldn't give you the 1/3, and they'd say c times e to the minus t over 3. They say, oh, well, find it. And all you got to do is just make sure that that integral, namely this condition, is true. From negative infinity to infinity, your probability density function integrated will give you 1. But this is a little more elegant, and you'll probably see it more often. And it says, look, you have a probability density function. What I'm interested in knowing, let's keep the same scenario so we have some sort of context. So you have this probability density function that tells you how long you have to wait before each time you blink, between each time you blink. And what I'm interested in knowing is the probability now that it's going to be between 2 and 5 seconds. Okay? So we're going to go ahead and do it. We're going to say, okay, well, the probability that you're going to have to wait between 2 and 5 seconds is just the integral from 2 to 5 of my probability density function. 1/3 e to the minus t over 3 dt. Easy enough. It's a pretty simple integral to solve. Okay? And then I'm going to do this. Evaluated at 2 and 5. Now I'm going to say 9 minus 1 over 9. Then I'm going to actually plug in my values. I'm going to get e to the minus 5/3 minus e to the minus 2/3. I can clean this up a little and say e to the minus 2/3 minus e to the minus 5/3 all over 9. And that is my answer. Okay, so you see, the math is pretty easy. This section has pretty nice math. Sometimes if you're faced with the question that I just said before this, you may have to do a little bit more calculus than this. but usually the math doesn't get too hard. Okay? So there you have it. That's probability distribution function.